Hello, so my name is Timo. I came all the way from Germany to tell you a little bit what we are doing at Joinswarm. And actually, we completely made up this title. But I found something that's kind of interesting about it. So you can drive as fast as you can on the Autobahn. You don't need to, but you can. And this was some of the motivation, to have a lightweight stack where we can deploy applications to distributed software. And but fast has lots of different dimensions. And so it could be low latency. It could be high throughput. It could be fail fast. And it could be, minimizing the time to recover instead of maximizing the time before failure. And, we have this popular animal in Germany, which, everybody's looking for, that doesn't exist, actually. So there is no one size fits all, and I think that's one thing we figured out. We released our open alpha platform in December, and so we have a past experience in the beginning, but then you can start your own systems within containers. Let's say you want to use the HashiCorp products, or you want to use Kubernetes. And you can start those things on top of Joinswarm. So in the end, we're a container infrastructure and not the PaaS, because we don't want to stay in the user's way. And if you look at all those different use cases, the customer always has a reason why they're doing this. And so there's no one size fits all from our perspective. And so we have different pluggable solutions. You can use, let's say, networking with L2 tunnels, because your software needs that. Some customers are, for instance, using Vertex, which uses Hazelcast, an event bus that by default discovers its peers through multicast. And for them, that was a transparent service discovery, and it was just zero configuration, and it was an advantage for them to have an L2 network. In general, you would say, okay, I want to have my raw network speed, and I would, if you want to hear about it, go upstairs and hear the Calico talk. That's a really interesting networking solution for containers. So, but there are reasons to have multiple of them, probably. And so another dimension of fast is to get fast feedback if you develop such a stack. Because I have a Linux machine, and then I develop a distributed environment on top of CoreOS, and I have to start virtual machines for it. That sucks. I don't want to start virtual machines that take ages to spawn up, or maybe to create another image. So last summer I wrote a little Go wrapper around systemd and spawn, which actually allows me to oh, this is wrong. Oh, I have to do the full screen off, probably. I'm on a Linux machine, I'm just don't get it. Yes. So going there. This has changed, but I'm in the Tmux session here. Yes. So maybe I have some more room. That's nice. Is that fine? Yeah. So what actually can do with that systemd nspawn wrapper I wrote in Go is like having a kind of like Docker workflow to build systemd nspawn containers. So who of you used nspawn before or looked at it? So what Leonard told us this morning is that you can start containers with Btrfs, similar to what you can do with Docker, but they don't have a format to create those containers. So you can fetch tarballs, for instance, or you can even fetch like Docker images. But I wanted to have systemd inside of the container because I wanted to have CoreOS in that container. So I needed systemd and Fleet so that Fleet can talk to systemd. So I'm actually booting systemd inside of the containers, and I'm using Arch Linux. So I created Arch Linux images, and so you can do Conair images, which is actually nowadays, no, this was wrong. Nowadays, just a wrapper around machine CTL list images. Like before, I had my own, but you know, the systemd guys are implementing all the stuff. So I just throw it away again, and I don't need it in my Go wrapper. So this is, you know, machine CTL list images lists all of the images you created with like downloaded with machine CTL, for instance. But there are also my Conair containers that have like a Docker workflow. I have a Conair file which looks similar to the Docker files. It's just it's on GitHub. You can try it out. So what you actually do is you create a base image that creates a minimal Arch Linux, and then I have like one image that just has Docker inside, and one image that has like the CoreOS components inside. So what you can do with it is you can just do conair run CoreOS alpha, and now I have a CoreOS running, and it's running. So I can do the status of etcd, and it's running. And you know, if you do this with virtual machines, it takes a lot more time. So I can just remove it again. And now I want to show you, let's do it here, how to do this. Oh no, this one was wrong. What's it doing? I don't have a machine running. So I'm starting 3 machines. I'm starting a cluster, which is actually it has a little bit more like our cloud config is integrated into the 3 containers. So there are a couple of services or configurations we use like in production environments, and I just put those things into the container. I actually start a similar thing like the CoreOS cloud init inside of the container, and so they are configured. And now I have those machine CDL, like 3 machines, and I have an alias called Flottenkommando that is actually, you know, Fleet with the parameters to talk to that local cluster, and I do list machines, and there they are. So if you want to see that again, I'm just deleting and creating them. And I do list machines, and it's failing. That's the first, second, third. It's really fast. And now I can do, I can just deploy our stack on it. So I do a watch over here. So there are a couple of utils and a service load balancer. You know those components from Kubernetes, like like it's very similar with what we came up with, and so there are a couple of like service discovery. Actually, here I'm also starting Weave, and it's always the one in the middle that fails. I'm not sure why. It says it's already running, but yeah. Yeah, the most important part is that I have like our HA proxies running, and I have like the app service running, and now I can talk to that cluster with our CLI. So I just do a swarm ls, and the service discovery needs, like the load balancers need some time. There they are. So I have no applications. I do swarm env. Oh, I'm in production. I go like to a dev environment, and then I have an example app, and I just do a swarm app, and I create an application on top of the 3 CoreOS containers. So here you can see there are 4 services starting now. They were these are fleet units generated by the app service, and yeah, it's running, and I have like curl ping local giant swarm IO should say hello. It's running. And I can do a swarm ls. I will see the application. I do status. I will see the containers that are running. And if I get this one, I can do swarm exec, which is similar to Docker exec, and just, you know, went into the container that is running on that cluster, and I can see, you know, what's inside of the container. And yeah, so I was bored in the plane, and this whole setup works without internet connection. I have a pretty shitty internet connection at home, so I'm living on the countryside in Germany, close to the Dutch border, and this is really the worst place you can get to have like no mobile and no like real internet connection. And up until recently, I had like a really shitty laptop as well. So, but I consider this as an advantage because like having, you know, if you have a full-blown IDE, you will probably produce bloaty software instead of like having a VI where you have like microservices, right? So, and the same thing goes for your laptop. So if you have a pretty shitty internet connection and a shitty laptop, you most likely produce a lightweight stack, right? So, so this was an advantage, but it was, you know, I was afraid that it will break on the next trip, so now I have a newer one, which is awesome. So I was bored on the plane, and so I came up with, you know, doing a Hello World a distributed way. So I have created a Hello World that is consists of microservices, and I'm going to start this, but I'm switching over to the slides again to actually explain a little bit what's happening there. So what we're doing, like when I started that ping service, it was just one container actually, like the payload that comes from a user starting a container on our platform. But there were like 4 services running, and those services are actually configuring that one container to have like single responsibility about like configuring stuff and doing service registration, and actually simulating the way how Docker works locally on the developer's laptop. Like if you use something like Docker Compose, those containers are linked, and we're simulating that in our environment, but those containers are running across hosts. And so you need a couple of things to do this. And so we have a similar concept to a pod, but we're doing this in systemd. And so we have different units that pull the image, they configure the storage, they configure the networking, then we have the container, and then the service gets registered. And this is the, like in Kubernetes, it's the single deployable unit. And the fun thing is, if you do this by requiring in one direction and requiring and after in the other direction, it's actually that if you do a system CTL start or a fleet start of any of those units, it will start with the first one, then the second, and go in that direction. And if you stop it, it will just go the other way around, which is kind of nice because you can just gracefully start a service and then deregister and unconfiguring those kinds of things. And with on top of CoreOS, you can also do this in a distributed way. Like you can chain those things across hosts. So you have like 2 pods, and then you have like the first one starts with the configuration, and the second one has an ambassador, or maybe like we have different ones. The ambassador has a reverse proxy that looks into the service discovery if the database, for instance, is already there. We also have that by just having a distributed lock, so it's just sitting there and waiting, and so it's a process running. And with systemd you can do a systemd notify, so and it waits until the other pod has started, and then does the systemd notify, and actually then it looks like service is registered, the ambassador finds out, and the rest is started. And this is how that works. And this is how it should be. This is how it is, and this is it's far from optimal, and like we're most likely moving our own containers over to Rocket very soon, because we have like lots of problems with Docker in production, and like we really want to have like this single source of supervision and not the systemd managing the Docker clients and then Docker managing the containers. So yeah, this is how it looks in production. So they're immutable, ephemeral, and scary. And this is my Hello World example. So I wrote a little Go tool called concurl that curls a service and then concats that to another output. And so I came up with a distributed Hello World. So I have like microservices, one microservice called Hello, one called World, and the other one is the Hello World combination, like maybe the API. You have 3 components within those microservices. One adds, the EL, the low, and the H. And this is how it looks like. So these are like, if you look at the top, the concurl dep hello world. Hello is the host name, and world is also a host name, and it does a curl to that host name. And let's see if that works. So there are a couple of units now inside of those containers, and I have hello.local.giantswarm.io. It says hello. world. And now the combination. Yeah, it works. So yeah, this was for the fun of it. But you know, I can throw away that whole thing again. No, I'm in the wrong folder. So I'm just throwing away the whole cluster again, and I have a new one. And that's my whole point, like having feedback, instant feedback, and not the feedback of like, I'm going to start those virtual images and I go grab another coffee and wait until the thing is ready. I think this is kind of essential if we want to build such a distributed system to have like instant feedback. Because it's rather complex. You've seen the Hello World example. It's like, a Hello World is simple, but the distributed Hello World is like, it's already like, why is it so complicated? Yeah. So this is my whole point. You can try it out. CoreOS, like it's my GitHub handle is Timo. Let's see, it's over here. Yes, so you can just try it out if you want to, go for it and have an Arch Linux that, simulates what CoreOS does. One nice thing is that you can change like the versions easily. So you can use like that Fleet version against that LCD version if you like, and if you just want to play around, and it's just a matter of seconds to try this out and like to have a different Docker version and stuff like that. So it kind of helps when you build a system on top of CoreOS. Thanks. Questions? Oh yeah, that's a JSON file, and actually it's kind of hard to read that, so I skipped that. I mean, it's JSON, so you can just have a look. It's I mean, that's the whole thing. We try to be kind of simple instead of like having like pod configuration and service configuration, like multiple JSON files. So it's all in one JSON file, and you can configure dependencies within, like similar to what you do with the Docker Compose YAML. Like so many people are asking us to do YAML instead of and TOML, and don't, whatever. It's JSON right now. So that's how I configured it. So you have a service called Hello World that combines hello and world, and you define the dependency on hello hello and world world, which is defined here. You have a service name called hello that has the component hello, low, and it's kind of hard to parse that. But that's what I showed in the diagram, mostly. Yeah, and you can add domains here. So that's the hello domain, and it will be registered in our HA proxies automatically, and yeah.
Are there any additional, or like, what are the next steps for working on this, as far as?
Like the local development environment?
Yeah, like what do you think that you could do to optimize your workflow for how you're doing things?
I mean, like with the recent system versions, I'm more or less replacing stuff within CoreOS, and I don't need those things anymore. And I even moved all the stuff into Valib machines, and I also wrote a small like loopback that will be a feature of systemd 220. So I have to run it as root, yes. So I don't have a root Btrfs anymore, and I was sick of it. You know that. And so I have like this loopback device that is actually mounted to Valib machines. And that will also be a feature of systemd 220. And so I don't need that anymore. And so I'm really looking forward in using more and more just systemd instead of what I wrote around it for my workflow. And I think it could be also interesting for production. Like it could be really interesting to have that nspawn containers running systemd inside of containers in production. Like usually I would totally agree with just running like 1, 2, 3 processes, maybe with that container injection in production, where you have like containers injecting into the namespace something to configure or something that fetches logs or something like this. Yeah, also using systemd inside of the container gives you some advantages, yeah, it might be interesting. Like even if you have like huge bare metal machines and you want to, test things on those machines, running containers with CoreOS inside of those big bare metal machines maybe makes sense. Yeah.
Any other questions?
Beer.
So where would that leave Docker then? I mean, I'm hearing that you're going to go towards systemd and spawn for your container.
Yeah, no, I think Docker won't go away from the developer's laptop. So we are likely to make the experience for the developers easy and like it should I don't know if we're gonna start Docker containers with Rocket or with systemd nspawn. That depends on like do you have to replicate the errors, like the bugs Docker has, to have like a dev prod parity for the developers, which they are expecting, because they can start that container, and this container is going to production and it should behave the same. So I'm not sure if we're going to replace Docker for the user container actually. But we are definitely replacing all of our tools and putting those into Rocket containers. Most likely Rocket and not systemd nspawn. I think systemd nspawn is really interesting if you want to really start systemd inside of the container and have more like a VM experience inside of a container. Thanks.